Okay, the second part of Chapter 5, Section 4 is to factor completely. Okay, so we have some general guidelines to factor completely. All right, so I think I prefer like a flow chart with this. So what we want to do is we want to start with, is there a GCF? Okay, uh, so that's the first thing you do. GCF, just like before. Is there a GCF? Okay, after you check with GCF, you want to ask the number of terms. Okay, so once you ask that, okay, you can get particular answers. Okay, you could have two terms, 2, 3, or 4. Okay, so in two terms, you want to ask yourself, is it a difference of squares? Okay, so after you get a GCF out, remember you're checking to see, is it a squared minus b squared? And then when you have four terms, you're going to check to see, uh, can you group? Can you factor by grouping? Okay, and if you're at three terms, okay, if you're at three terms, you've got a lot of options. First thing you want to check is it a special product? Okay, for that particular case, special product would be what? It would be a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. It's not a special product. Our next step would be to ask, it goes so no. That's a yes if it's special. No if it's not. Okay, it goes there, there. Okay, so no if it's not. You're going to check, is a equal to 1? Okay, if that's a yes, then you look for factors of C that add to B. And if it's a no, if A is not equal to 1, in other words, it's ax squared plus bx plus c. Over here was x squared plus bx plus c. Then we got to do factors of AC that add to B, and split B, and then group. Okay, so that's your general flow chart. You check for GCF, then check your number of terms, 2, 3, 4. Difference of squares, factor by grouping for 2 or 4. If it's 3, check to see if it's a special. If it's not, decide if you're going to do factors of C that add to B or factors of AC that add to B, then split B and factor by grouping. So let's just do some examples. Example 1 is z cubed plus 4z squared minus 9z plus 36. So we have, if we come and look at this, we have no GCF. We have 4 terms. So we're going to look to group. Okay, so if I group this, I come up here, start grouping that, and that with addition. I get a z squared out of the first thing, left with a z plus 4. I get a negative 9 out of the second thing, of the z minus 4. Oh, this is, wrote it down wrong. Minus 36. And a z plus 4. Now I have a common term because I'm factoring by grouping, z plus 4. Z squared minus 9, but I'm not done. I'm not done because that's a perfect square trinomial. So I check my binomials. I got 2 of them. That's z plus 3, z minus 3. Okay. Let's look at the next one. Example 2. Be 3x squared minus 48. It does have a GCF. The GCF is 3. So I'll pull the 3 out. And I'm left with x squared minus 16. And that's the difference of squares. So that's x plus 4, x minus 4. Okay, so this is GCF, CF, and this is difference of squares. Okay, looking at another example. X squared minus 3x squared minus 4x plus 12. It's 4 terms with no GCF, so we look at factor by grouping. No GCF. No GCF. 4 terms. Group. Okay. So if I'm grouping, do split that, and don't forget we want to keep that. Don't split the negative. And so I can pull out an x squared. I'm left with an x minus 3. Pull out a negative 4. I'm left with an x minus 3. Similar to the one I just did. We've got our common binomial factors. Pull that out. That's a difference of squares. So we got to factor our difference of squares. X minus 3, x plus 2, x minus 2. Okay. Do one more. Example 4 is 4x squared y squared plus 12xy squared plus 9y squared. So I'll look for a GCF. There is a GCF. GCF is y squared. So I'm going to come over here and I'm going to pull that out. Y squared leaves me with the 4x squared plus 12x plus 9. That looks like it might be a perfect square trinomial. It's 3 terms. Okay. Perfect square trinomial. Let's check. Still got the y squared that didn't disappear. Is 12x. So this is probably, we can rewrite that as 2x squared plus 3 squared is 12x. 2 times 2x times 3. 2 times 2 is 4 times 3 is 12. And so yeah, that does factor as a perfect square trinomial. Okay, here's where we do the you try part. So I'm going to put up 3 problems for you to try, and then pause it and try the problems, and then I will come back and check them. 12x squared minus 75x, that's x cubed, not x squared. A squared b minus 7a squared minus b plus 7, and 3, 4x cubed plus 28x squared minus 120x. Pause it. Okay, I'm going to work it from 1 for GCF. 3x comes out, and you get a 4x minus 4x squared minus 25. So the 3x, that gives me a 2x plus 5, 2x minus 5, because that term is a difference of squares. All right, doing number 2. It's 4 terms, so with no GCF, so we're going to factor by grouping. Take that. So I've got an a squared that comes out of that, -1 that comes out of that, and then I've got a b minus 7 that comes out. And now I have something that is a difference of squares again. You'll see difference of squares a lot, so get comfortable with it. A minus 1, a plus 1, and then coming over here on 3, is there a GCF? There is a GCF. A 4x comes out, and left with x squared plus 7x minus 30. Okay, it's 3 terms, but not a perfect square trinomial, because 30 is not a perfect square. A is 1, so we're looking for factors of negative 30 that add to 7, 10, and negative 3. So I get 4x, x plus 10, x minus 3, that equals that. Okay, that's it for Chapter 5, Section 4.